Here's some computer graphics showing what we're doing with the shell method. So here we go. The x-axis is running this way. The y-axis is going up. In that xy plane, I've got the line y equals x, and the curve y equals y equals x squared. Right? So between 0 and 1, I've got a bunch of these little rectangles. I'll show you them one at a time, but I can slide them around, and you can see that the top of the rectangle is always on the curve y equals x, and the bottom of the rectangle is always on the curve y equals x squared. Okay? Now, what I'm going to do is I'm going to take those two curves and that rectangle as well and rotate them around the y-axis. So here it comes. It's going to start rotating out at you. It rotates across in front, and then it goes back down around behind, and of course it's going really slow again. Oh, I think I dropped it. Let's pick it up again, and there we go. Rotate it all the way around to the other side. So you can see that the parabola there generates this, it's called a paraboloid around the outside, and I've drawn that partially transparent so you can see through into the line, which is generating a cone. That rectangle generated a washer in there. Not a washer, it generated a shell. That's the whole point of this section. It generates a shell. And as I move that around, you can see that they're generating different shells. Each x value has a shell associated with it, all the way from very small shells for small radius, small height there, medium-sized radius with a bigger height, and then you get way out to the outside and you get really big radii, but the two curves are coming back together again, so the shells are really very short. Okay? Each one of those you calculate a volume and then add them all up. In fact, let's do this example in the next video.